All right, so this is assignment 3-2, and we'll be doing the assignment together so we can learn it together. In number 1, so first of all, the assignment was on different rules that we can use as a power rule. So that would be the product rule, that would be the quotient rule, and knowing how to use our calculator to differentiate. So this is a review from the summer when we learned about the product rule and the quotient rule. So we're reinforcing it, maybe adding a few extra things to it. So number 1, and it says to simplify your answer. So because it tells me to do that, I will. So x squared subtract 2, 4x plus 3. So I want to use the product rule. So the product rule is the first, x squared minus 2, times the derivative of the second. So this is the first, this is the second. So the derivative of 4x plus 3, that's 4, plus the second, 4x plus 3, times the derivative of the first, and that's just 2x. If I wanted to simplify it, we go 4 times x squared, we go 4 times negative 2, we go 4x times 2x, which is 8x squared, and 3 times 2x, which is 6x. And then putting it all together, 4 plus 8 is 12x squared plus 6x minus 8. And that's it if you simplify it. Number 2 says differentiate without using the power rule. So can you do algebra first and then do the power rule? So a different way to get the same answer. So step 1 here would be to distribute, to FOIL. And then after you FOIL, to use the power rule. So x squared times 4x is 4x cubed. X squared times 3 is 3x squared. Negative 2 times 4 is negative 8x, and negative 2 times 3 is negative 6. Then just do the power rule. So 3 times 4 is 12x, and subtract 1 from the exponent. 2 times 3, that's 6x, subtract 1 from the exponent, and negative 8x is just negative 8. And negative 6 is 0, so we don't need it. And now you can compare. You could see the product rule, or doing algebra first and doing the power rule, they give you the same answer. Number 3, use the quotient rule. So we use the quotient rule when 2 are dividing. So we have 2 expressions dividing, x squared minus 4 and x plus 2. So we're going to use the quotient rule. So the quotient rule is the bottom times the derivative of the top minus the top times the derivative of the bottom. Now the derivative of the bottom is 1, so I don't need a 1 there, but I'll put it there for fun. And then the bottom squared. Now, if I wanted to simplify this, it would be x times 2x, which is 2x squared. And then 2 times 2 is 4x. And then minus x squared, and then a negative and a negative make it plus 4. I'm going to keep simplifying this. I just want you to show it's going to be the same as number 4. 2x subtract 1 is 1x squared plus 4x plus 4. Then the factor the top out. So 2 numbers that multiply to 4 and add to 4 are 2 and 2. And because they repeat, 2 and 2, I can write it as squared. And then what do you notice? Is they divide out, and then what's the answer at the end? Just 1. That's it. So using the quotient rule and simplifying, the answer is 1. For number 4, what would happen if I did algebra first? So if I did algebra first, the numerator, x squared minus 4, would be a difference of squares. So I'd factor first. Then what do you notice is that x plus 2 divide out. So all you're left with is x subtract 2. Then what's the derivative of x? 1. and the derivative of negative 2 is 0. So they match. So if you think, hey, which one's better, easier, and so on, I think you're thinking this. And this is a pretty basic rule that we use in calculus, that always look at the algebra to make the calculus easier. And if you're going to have a frustration, it's usually not calculus. The frustration is the algebra that leads to the calculus that sometimes lets you down. All right, so we're trying to look at algebra that can simplify something to make the calculus easier. Number 5, differentiate by any way you want. So I'll pick a method and I'll tell you why, what I'm looking at while I do it. So the first thing I look at here is that the denominator is a monomial. That means that I can separate this into 2 fractions and make it much easier to differentiate than using the quotient rule. So 12 divided by 4 is 3, x squared, and negative 4 divided by 4 is negative 1. Then when you take the derivative of this, it's just 6x. Done. If I don't see the algebra to simplify it, then I'll use other rules. F of t equals 1 over t squared, and then we have t cubed minus t squared. So what I notice when I distribute here is that this can be a lot simpler. When you multiply 1 over t squared and t cubed, I'll write it on the side, this is what you end up with. So when you multiply them together, you end up with t cubed over t squared. Subtract the exponents, that's just t. And when I go 1 over t squared times t squared, well, they divide out, and that leaves me just with 1. So that when I take the derivative here, the answer is just 1. Number 7. So again, what I look at, what's the algebra I can do to make this simpler? So I'm going to distribute. So that is going to be 2x squared plus 10x subtract 6 when I distribute. Then I'm going to take the derivative and get 4x plus 10. So I'm looking for the algebra to make it simpler. Number 8. In number 8, I look to see, is there something factorable where I could simplify to use algebra? And the answer is there is none. So in this situation, there's no algebra that I see to simplify it. We're going to use the quotient rule, and I'm not going to simplify. So the quotient rule is the bottom times the derivative of the top, subtract the top times the derivative of the bottom, that's just 3, and then take the bottom and square it. Done. Number 9. So for number 9, I see a way to simplify it easily. So the square root of x is x to the 1/2, and then we have x plus 1. So I can distribute first x to the half times x to the 1, just add the exponent. So 1/2 plus 1 is 3 over 2, or 1.5. X to the half times 1 is just x to the half. So now I can just use the power rule, and I don't need to simplify. So 3 over 2 times 1 in front, and then subtract 1 from the exponent. That's 3 take away 2, so that's positive 1/2, plus 1/2 times 1 in front is 1/2. Subtract 1 from the exponent. Again, the quick way, the little shortcut there is just to go the numerator subtract the denominator. So 1 take away 2, that's negative 1/2. And it's done. Number 10. So for number 10, I see x squared minus c, and I see x squared plus c. And it says c is a constant, some number. I don't see any way algebraically to simplify this, so instead I'm just going to use the quotient rule. So the quotient rule is the bottom times the derivative of the top. X squared is 2x, and the derivative of any constant is 0. Subtract the top, x squared subtract c, times the derivative of the bottom, which is 2x, and then take the whole denominator and square it. Number 11. Now, from number 11 on, these are review questions. So find the second derivative of that. So we have y equals, and I'm going to write this as 4/3 x cubed. Means the same thing. So when I take the first derivative, I'm going to go 3 times 4/3. The 3's divide out, so I have 4. Subtract 1 to the exponent. Now the second derivative, 2 times 4, that's 8. Subtract 1 from the exponent, and that's 8x. Done. Number 12. Find an equation of the tangent line. So as soon as I hear that, I'm going to set this up. I need to know the x-coordinate, the y-coordinate, and the slope. So for number 12, the x-coordinate is -2. The y-coordinate is +2. And then the slope is going to be the derivative at -2. So first I need to know what the derivative is before I can plug in -2. So for number 12, I see x over x plus 1. I got to use the quotient rule. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. Now it might be easier to simplify this before I plug -2 in. So x times 1 is x, and when you subtract x, the x is actually crossed out. So I'm only left with 1 on top and x plus 1 squared on the bottom. Now plug in -2. When you plug -2 in, -2 plus 1 is -1, but when you square -1, it's positive, and 1 divided by 1, so that whole thing just gives you the answer 1 for the slope. Now put it together. So the equation of the tangent line then would be the slope, +1, change the sign, x plus 2, keep the sign, +2. You could also write that answer as x plus 4, same thing. Number 13. Number 13, it says, find the x-coordinates of points at which the graph of that has a tangent line parallel to that graph. So we're finding the x-coordinates only. So first of all, I'm looking for the x-coordinates. I'm given a function, g at x equals, and it's 2x minus 1, x squared plus 3. And when I see the word tangent parallel to something, that means I need to take the derivative. So we can distribute or we can do the product rule. So what I'm going to do is some algebra first. So 2x times x squared is 2x cubed. 2x times 3, or let's do this one first. -1 times x squared is -x squared. 2x times 3 is 6x. And -1 times 3 is -3. So the derivative here is 6x squared minus 2x plus 6. So I took the derivative. Then it says parallel to that graph. So parallel means the same slope. So when I have y equals 6x plus 1, same slope means, hey, what's the slope of this line? So we're going to take that and we're going to make it equal to 6 to find the x-coordinate. So parallel means the same slope. What is the slope? 6, and then we're going to solve it. So we're going to subtract 6 to both sides. That gives me 0. I'm going to factor out a common factor, which is 2x. And then there are two answers here. So 2x gives me the answer 0. 3x subtract 1. That means I add 1 and divide by 3. So one x-coordinate is 0, and the other x-coordinate is 1/3. And that's it. That's what I'm asked to find. Find the x-coordinates. So again, the word tangent means derivative. Parallel means the same slope. Make them equal to each other, solve it, and you're done. 14. Find the average rate of change. So AROC means algebra. So that would be f at 3 minus f at 0 all over 3 take away 0 to find the slope there. So we're going to plug in the function is 1 over x plus 1. So I'll even put that here. 1 over x plus 1. That's the function we're using. So if I plug 3 in, 3 plus 1 is 4, so that's a quarter. Plug 0 in, 1 divided by 1, that's 1. And then that's 3. Now if I wanted to simplify this, I would change the 1 to 4 over 4, So 1 take away 4 is negative 3/4, and then times the reciprocal, the 3's divide out, and you get negative 1/4. The power in that is when you have a multiple choice question and you need to be able to find your way through to finding that answer to be able to circle. Number 15, find the rate of change. Not the average rate of change, but just the rate of change. So the rate of change then would be the derivative of that up there. So if I was going to find the derivative, there's a few different ways that you could find the derivative. But let's use the quotient rule because we've been doing that. So that's the bottom times the derivative of the top minus the top times the derivative of the bottom, and then the bottom squared. So if I simplify this, you get negative 1 over x plus 1 squared. Oh, and it says when x equals 2. So there's the derivative. So the derivative at 2, you would just plug 2 in. So 2 plus 1 is 3, and then 3 squared is 9. So it's negative 1 over 9. Number 16. Given that g at x equals x times f at x, so given that, use the product rule to find the derivative. So if that's what I'm given, what's the derivative of g? So this dot means the product rule. So that's the first times the derivative of the second plus the second times the derivative of the first. In part B, if f at 2 equals 3 and the derivative at 2 equals negative 2, find the derivative at 2. So what's the derivative at 2? Notice the x coordinate is 2. So wherever there's x, I'm going to plug in 2. And then times 1 doesn't change anything. So we have 2. What's the derivative at 2? Well, in the question it says the derivative at 2 is negative 2. What's f at 2? Not the derivative, just the function value at 2. And in the question it says that answer is 3. And then just finish it off. So 2 times negative 2 is negative 4 plus 3. So the value there for number 16, the answer is negative 1. Number 17. H at x equals that. That is f at x divided by x squared. And then it tells you some values, like f at 2 equals 3, the derivative at 2 equals negative 2, and it says find the derivative at 2. So these are great like AP style kind of questions to see if you know the rules and can apply them conceptually. So the derivative here is going to be using the quotient rule. So that is the bottom times the derivative of the top minus the top times the derivative of the bottom, which is 2x, and then take the bottom and square it. So there's step 1. Now step 2 is can you plug in to find 2? So change every x value to 2. So if I change this to 2, you get 2 squared, and then the derivative at 2 minus f at 2 times 2 times 2. So wherever there's an x, put in a 2, lot of 2's, and then simplify it. So let's simplify this. 2 squared, that's 4. In the question, what's the derivative at 2? Well, that's negative 2 right here. And then subtract. What's f at 2? That's 3. And then 2 times 2, that's 4. And then the denominator, 2 squared is 4, and 4 squared is 16. This is negative 8. Subtract 12 over 16. That is negative 20 over 16, and that's a good answer. Negative 5 over 4 could also be an answer. Done. A little bit more challenging, right, to be able to apply the concept here. Number 18. Number 18, they said the volume of a cube is that, where that's one side of a cube, and then you cube it to find the volume. Find the rate of change of the volume with respect to the side length when s equals 4. So rate of change means derivative. So what is the derivative here? That's 3s squared. Then say take the derivative, and when the side is 4, what's the rate of change? So plug in 4, and that's 3 times 16, or 48. They don't give you any units, or else you could actually write it as a rate with units. And if you did, it would be the volume over whatever the time is for the rate. Number 19. In number 19, a particle moves horizontally, and you're given s equals t squared subtract 5t plus 4. It says, when is the particle moving left? So this is giving you the position of the particle. So in order to do that, I need to find the velocity. So I need to take the derivative of that. And then you need to take the derivative, the velocity now is what you have, sorry, and make it equal to 0. Because I need to know when the particle is stopped. So I'm going to add 5. I'm going to divide by 2. So 5 divided by 2 is 2.5. So this is a conceptual question, not a real world situation. So time can be negative. So if I put 2.5 here in understanding the velocity, to the velocity, I'm going to plug in any number bigger than 2.5, like 1 billion. So if I plugged in 1 billion, it's obvious that the answer is positive. Plug in a number smaller than 2.5, like 0, and that gives you a negative answer. So the question again is, when is the particle moving left? So that means left. So the answer is from negative infinity to 2.5, the particle, so this is negative infinity to positive infinity. So from negative infinity to 2.5, the particle is moving left. Number 20. Number 20, you got to look off a graph. So let's put the graph up here. At any time you can press pause, do what you need to do, come back to it. I get it. So this video is here to support you to finish your assignment. So number 20. Which is greater, the average rate of change between A and B? So if I look at average rate of change, that's the slope between A and B. So make that slope right there. See it? Or the instantaneous rate of change at B. So do you see right at B, draw a tangent line? Means just draw a line using the 1 point. And I want you to notice that A to B is steeper than doing a tangent line at B. And because it's steeper, the average rate of change is greater. So, which one is greater? And the answer was A rock is greater. Why? Because the slope from A to B is steeper than the slope of the tangent line at B. So A rock uses 2 points. I rock just uses the 1 point. And we're looking at the steepness of that. Which one is greater? 21. It says copy the figure on your own paper and sketch a tangent line which intersects the curve at C and D and whose slope is equal to the average rate of change. So for 21, if I copy this down and I see A, I see B and C, and I see D. So that's what I see. I'll draw this and then have a bit of a sketch. And then the question is that from A to B, you have this line, and it says, draw a line that intersects the point C and D whose slope is equal to it. So between C and D, oops, I didn't need this one, but I did need to connect C and D. So if I connect C and D, the question is, can you draw a line with the same slope, parallel, but only touches the curve at 1 point? So I'm going to make it parallel, and it's just going to touch at one point, but make it parallel. A little conceptual, right? So ignore the A to B part. Connect C to D, and then draw a line parallel that just touches the curve right beside it. 22. The height in feet of a rock thrown vertically on the moon is given by that equation. So h equals negative 27 over 10 t squared plus 27t plus 6. And this is t is in seconds. And then h is in feet. When does the rock reach its greatest height? So it's going to reach its greatest height, and you're first going to take the derivative of this. So if I go 2 times this, 2 goes into 10, 5 times, subtract 1 to the exponent. The derivative of 27t is 27. We need to make that derivative equal to 0. Because if we make the derivative equal to 0, what we're finding is that where it changes, like velocity. You know, when velocity is 0, we're looking to see when it changes direction from left to right. In this case, the derivative here, when we make it equal to 0, we're looking to see where it changes from rising to falling in terms of that. So we're going to solve it. So step 1, subtract 27. Step 2, we're going to divide. Now, when you divide by a fraction, it's times the reciprocal. And I want you to notice the negative and the negative make it positive. The 27s divide out, and the answer is 5. So at 5 seconds. Now it says, how high is it? So first of all, at 5 seconds, it reached its maximum height. That's the same as asking for the x-coordinate of the vertex. Then go back into the main function and plug in 5 to find the actual height of what that is. So I would expect you to use the calculator. I have an answer key, so I know you can plug that in. You can practice with the calculator if you want, but plug 5 in, and you'll see the answer is 73.5 feet. 23. If f at x equals that, use a calculator to graph the function. Also find the derivative 1 and the derivative at 2. So let's do that. So we're going to use our calculator. And the last time I used the calculator, the lighting then kind of went a little crazy. So we'll see if we can make this work. So I'm going to clear what I have. And I'm just going to start. So the graph itself, oops. Let me clear this out. So I'm just going to clear this document out that I have. All right, let's see what we got. So, Grace is pretty and nice. That's my daughter that wrote that. I'm glad she thinks she's pretty and nice and she typed it out. All right, let's see if we can do that. Do you want to save it? Sure, I want to save it. Whatever. Document 1 is fine. That was funny. I had no idea. She typed in. Okay, here's what you see, right? And so we want to graph. So we're going to press B to graph. And then here, where I see it, I am going to, if you have something, you can press Menu, Actions, and then you can delete it all. So you can kind of start from scratch. So I'm going to press the Tab button, and then I'm going to just type in what it tells me to type in. So to type in, I want to do the derivative of that. So to do the derivative of it, first of all, I'm going to go Menu. I'm going to go, let's escape that. All right, so I'm going to actually press this button down here. So the button is right beside the number 9. That quickly accesses a bunch of things. So right beside the number 9, it accesses a bunch of keys on the calculator. I want you to go to the derivative button there. So I'm going to move to the right until you see it. So practice, see if you can find it. Press enter. So there's the derivative button. The variable's x, and then I'm just going to type in what it tells me to type in. So that's 2x squared, so parentheses, 2x squared, subtract 1, move the cursor, and then cubed. So it says use a calculator to graph the derivative. So I'm going to do that. Now, oops. Now my window is like way off. So I'm going to go to menu, window, and I'm just going to do a standard window to begin with. So number 5, it just centers it to get a sense of what's happening. So there's a sketch of what the derivative looks like. So I'm just going to sketch. It says use a calculator to graph it, and then find certain values on the calculator. So step 1 is, could you sketch that? I'm going to do that myself right here, so you see it. So what do I notice when I do that? So I'm just going to pick out some points that I see. And then I'm going to connect them. So there's my sketch of the derivative. I kind of looked at where the intercepts were and where the turning points were and just sketched it knowing that we have 1, 1, 1 in all directions. So there's a sketch of the derivative. Then off the graph, how would you evaluate a derivative off the graph? So let me show you how that works. So if I want to know the derivative off here, I can go to Analyze. So go Menu, then Analyze, and then go to the derivative button, which is 6. So if I do that, it then asks for the position, which is another way of asking for the x-coordinate. So the first x-coordinate I'm looking for is +1. So I'm going to go +1, press Enter, and then look to see what the answer is. It's blinking at me. What's the derivative at +1? Oh, did it still not want to do it? So at 1, so what is the derivative at 1? All right, let's zoom in here. Maybe that's part of the issue. So I'm going to go Menu, Window, and I'm going to zoom in to be able to see the graph a little bit better, and hopefully I can do it. So I'm going to go Window Settings, and then I'm just going to make it a lot smaller. So I'm going to go -4, 4. I'm going to go, -4, 4. Just make the whole window smaller to look at. So there's my graph. Oh, you know what part of the issue is? Is that I graphed the derivative. So because I graphed the derivative, I don't want a derivative of a derivative. Let's see if we can do this again. Analyze. I just want to know what the function value is at that one. So off the graph, let's see if I can find the function value. I think maybe if I traced it, let's see what happens. So if I trace the graph, what's the value at 2? Or at 1, I should say. So there it is. So I trace the graph I want to cross. Oops, I went too far. Let's see what we got here. At 1, the answer was 12. You see that? As it keeps going past it. So at 1, the answer was 12. So the derivative at 1 equals 12. And then the question is, off the graph, can you find the derivative at 8? Now for me, I wouldn't do this off the graph. I would do it on a different feature just to be able to find the derivative really quick. So for instance, because I defined it already as the derivative, let me just show you what I would do, rather than this is being silly. I would go to calculate, it just has a mind of its own because I kept pressing it. And it's not stopping. There we go. Oh, it's like all crazy. We got this? There it is. It's defined as f1 at x. So I would type in f1 and then just put in 8 and then enter, and then it would give you the answer. So the other answer, one answer was 12, and this one here, the answer is, because I defined it in my calculator as f1 at x that I graphed, here f1 at 8 gives you like 1,548,384. And by the way, if I decided to put 1 in, the answer would have been 12. So anyways, once it's defined in your calculator, then you don't have to use the graph. Then you can go back and just calculate it. All right, that was a fun journey. All right, 24. Away with the graphing calculator. We're almost there. 24. If f of x is an nth degree polynomial, so that would be f to the n plus 1 x, it says find the, well, if f of x is an nth degree polynomial, find the next one. So if you add 1 to the exponent, what would it be? So that's what I'm looking for. So for number 24, suppose f of x equals x to the 4th. Then the derivative of that would be 4x cubed. The derivative of that would be 12x squared. Can you see what's happening to the degree? The third derivative of that would be 24x. And then the fifth derivative of that so the fourth derivative of that, put a little 4 there, would just be 24. And then the fifth derivative and on would be 0. So what would we say then? It says the answer to that would be for an nth derivative, the answer here would be 0. That's a way confusing conceptual question. I want you in your brain, you can let that one go. So again, if f of x is an nth degree polynomial, find n plus 1 x, like the derivative, all the way there, right? Whatever that is. And eventually what it's saying is, if you take the derivative enough times, n plus 1, eventually, way down the line, the answer will always be 0. That's what a very confusing way of answering it. So if you have a polynomial and you take the derivative enough times, what will the answer eventually be? 0. That's what it's trying to explain. I'm sorry, it's a headache. 25, but hopefully that makes sense. That if you have a polynomial and you take the derivative enough times, eventually the answer is going to be 0. All right, 25. True or false? Y equals f at x times g at x. That means the derivative is f prime times g at x. Is that true or false? And of course the answer is false. That is not. We'd have to use the product rule. So you don't just take the derivative and plug in times. Instead, it would be the first times the derivative of the second plus the second times the derivative of the first. That is not. But that's like the cheating way in your head you might remember the product rule. But wrong. What is the correct way? So that's wrong. The correct way to do it would have been the first times the derivative of the second plus the second times the derivative of the first. That is correct. This is true. That's false. 26. 4 more to go. In number 26, it says find the total distance traveled between 0 and 4 by a particle whose position is given by that. So you're given a position equation. So I'll write it down. Then, in order to understand the total distance, we have to know when the particle changes direction. So we need to find the velocity. So 4 times a quarter, that's 1. So it's 1t cubed. 3 times negative 3 is negative 9t squared. 2 times 4 is 8. And then negative 4 is 0. So if I make that equal to 0, and then I factor out a t, and then I factor more. So that is a trinomial. So the two numbers that multiply to 8 and add to negative 9 are negative 1 and negative 8. So the answers I get are 0, 1, and 8. Now, for number 26, it says between 0 and 4 seconds. So 8 is out of my interval. So it's just 0 to 1. In fact, 0, because I'm starting at 0, this one, the 1 is really the only one that actually matters. So from 0 to 4, the velocity, that's what I'm looking at. So at 0, it stopped, but I want to know between 0 and 1 what's going to happen. So if you plug in a number like 1/2, it's a positive times a negative times a negative. That means positive. So between 0 and 1, it's moving to the right. Now, what happens between 1 and 4? What's happening? So pick a number between 1 and 4, like positive 3. Positive, positive, negative. So if you put that together, it's going to the left. So for total distance, I need to do is I need to plug in and understand s at 1, s at 0, and s at 4, and use those numbers to find total distance now. So if I plug in 0, that's the easy one. That's negative 4. If I plug in positive 1, and I'd let you use your calculator there, it's negative 2.75 if you change it to a decimal. If you plug in positive 4, the answer is negative 68. So now how does that help me find total distance? So step number 1, the total distance from 0 to 1. So we have negative 2.75 subtract negative 4. That's what I would do first. So the end subtract the beginning. I do that here again. The end subtract the beginning, and you have to make sure it's absolute value, so these are positive distances. So again, the end at 4 is negative 68, subtract 1, which is negative 2.75. So we want to put this in our calculator and then write the answer as a positive. Now the first one actually will be positive, because when you subtract a negative, it's positive. So it's going to be positive 1.25. But the next one will be a negative answer. But you're going to change that negative answer to a positive answer. You're going to do the absolute value. So to be negative 65.25. But you're going to change it to positive 65.25 and then add them together. So the total distance here is 66.5 meters. All right, 27. 3 left. If f at x equals 7 to the x, use a calculator and find the derivative at 3. So let's turn on our calculators. We're going to calculate this. So first I'm going to press menu, and then I'm going to go to calculus and derivative. And it's a derivative at a point. So we're going to press 2. We're going to use the x value. And then what value? What's the x coordinate I'm looking at? For 27, I'm looking at 3. Then press OK. And then type in what it is. So it's 7 to the x. So 7 to the exponent x, not times. Control Enter. And you have the derivative. So what's the derivative at 3? And the answer is 667.447. Remember, always 3 numbers after the decimal. 28. 2 left. If g at x equals that, find, and again we're using our calculator to do this. We're going to make sure it's in radians. So g at x equals sine x cubed plus 4x cubed, and then we want to find derivatives at certain points. So let's practice the same thing we just did. So if I want to find the derivative at 2 or negative 4 or the second derivative, what would happen? So let's do that. So first of all, the derivative at 2. What would I press in my calculator? So let's do this together. So step 1 is menu, calculus, and then we want to find the derivative at a point, so number 2. Then the variable's x, move the cursor down, and then what x value? So 2 is what we're looking for, and then we're going to type in. So we're going to type in sine. Now to type in sine, we're going to press the trig button, that's beside the number 7. And then sine, and it's x cubed. I'm going to move the cursor past the, in between the 2 parentheses, plus 4x cubed. Control Enter. And you get 46.253, or 54. Next, I want to do the same work. I don't want to retype everything in, so I'll show you. So the derivative at negative 4. So to find that, we already did this work, right? So I'm going to highlight. I'm going to go back up and highlight, press Enter, and then all I need to change is this here. I need to change that to what number? Instead of 2, we need to change it to negative 4. Control Enter. And the derivative at negative 4 is 210.801. Or 809. $210, 809. Nice. Now, the last thing it says is the second derivative at 1. So how do I do the second derivative? So for the second derivative, we're actually going to press the button that is beside the 9 right there, just to the right of it. Press it. This will pop up. And we want the derivative box that gives me the 2. So this one here, if you press it, do you see the 2 there? That's what we want, x. If you want, we could actually go up and copy it and paste it in to make it just a little quicker to do. Just to teach you again how to copy or paste. If you go Control, copy, Control V is paste, Control C. So Control C. So press the Control button and the letter C, that copies it. And then inside the parentheses, I'm going to go Control V, and that pastes it in. And then obviously I can just go take cursor back, and I can get rid of the d by dx. Oh, it did it all. All right. Maybe I should just type it in. So sine x cubed probably was just as quick. You're trying to save time and you don't, right? And then it's plus 4x cubed. And then it's the second derivative at what x value? At positive 1. And you get the answer 0. Really? You did all that work? No. What did I do wrong? Oh, I know what I did wrong. So that parentheses right here, yep. Oh, see, I tried to save time, and I totally didn't save time. The problem is the parentheses needed to be there. Still not doing it. Okay, let's start again from the beginning. So the second derivative, type it in, try to save time, didn't save time. Trig sine x cubed, move the cursor, plus 4x cubed. Beautiful. Now outside the parentheses, I need to find and type that in. Now that little vertical line is when you go control equals. So if I go control equals, what will happen is, you see that, move the cursor to the vertical line and then press enter. And then type in x equals 1, and then it will be right. There it is, 19.668. Or 9. All right. So you don't have to round, you can truncate. Oh, let me just show it to you. There it is, 19.668. So I'm telling you the first derivative with your calculator is a little bit easier. For the second derivative, it takes more typing. I tried to do a shortcut by copying and pasting, didn't work. The more we practice with your calculator, it's going to feel like it feels with your phone when you do all your text and everything else. It gets super quick and you feel it, and it's like your phone. What happens when you get a brand new phone that's like not Android, it's like Apple or back and forth? It takes your brain a while to switch, right? To be able to get to things quickly and type them in quickly. But as we practice with our calculator, it's going to get better. All right, last question, number 29. So we're just going to read off the graph here for number 29 and then answer what we see. So for number 29, they give you the velocity of a rocket. So if this is the velocity, positive means it's rising. So all of this is rising. Now, the part that's rising means it's accelerating. This means it's still rising, but slower. This right here means it stopped rising. So there, when it stopped rising, it's falling and falling. Okay, just to get a sense. So what's happening again? Rising, rising, falling. Where does it go from rising to falling? Right there. But what happens when it's this? This means it's going up quickly. This means it's going up slowly, going down slowly, going down and so on, okay, at a different rate. So if it's above, it's up, down, it's below. Got it? Up, below, going down, going up, going down. Here we go. What was the rocket's greatest velocity? Right here, the highest point. It's 200 feet per second. Done. B. Estimate the velocity at 7 seconds. So if I look at 7 seconds, it's between 0 and 50. Oh, sorry, here, 7 seconds. So here's 7, right here. It's a little bit below 50. So you would estimate it at a number a little bit below 50. So like maybe 44. I just did that for fun. It could be some number that's a little bit below 50. C. Was the rocket moving up or down at 7 seconds? Is it above or below? Because it's positive velocity, it's moving up. But it's a trick, isn't it? Because it looks like it should be moving down because the line is moving down. But positive velocity means up. Negative velocity means down. So at 7, because it's positive velocity, it's still moving up. It says, estimate the rocket's speed when the parachute was released. So when do you think the parachute was released? So think of the rocket going straight up, and then you have a parachute. So what's happening? So when the parachute happens, it's still rising with the parachute, But is it rising as quickly as the boosters would have went up? No. So this is with the boosters. When do you think the parachute happened? Where it's still rising, but now it's going slowly as it's rising. So can you see that's at, where are we at? D. Whoa. So, I'm totally here. Okay, let's try this again. So we have the boosters. Then after the boosters, you let go of the boosters, but the momentum still means it's going up. Then the thing is released, the parachute, and then instead of rising after the parachute, it is going to fall. Let me have some sense. So what has happened for boosters? The boosters are off. The momentum keeps making it go up. Then the parachute comes out. Then it starts to fall. So estimate the rocket speed when the parachute was released. So booster, no booster. Now what's going to happen after a while is the momentum is going to go down on itself, right? So as it slows down, it's going to eventually fall. So booster, momentum, but now the momentum is now not going that way. And then where on this graph do you see a parachute? And when the parachute happens, it's going to have a little bit going the other direction, right? So it was falling, so the parachute kind of gives it a jolt. Can you see this little jolt right here? So what is the speed when the parachute comes out? Right here is the parachute. -50. But speed is written as an absolute value of that. So it's the absolute value of -50. So what was the speed? 50, and the units were feet per second. So when the parachute came out, that's what happened. So again, let me make sure I'm a good reader, right? The engine burns for 2 seconds. The rocket continues to coast upwards, then starts to fall. A parachute is released 10 seconds after launch. So there it is, 10 seconds. What's the speed there? And so on. So let's keep going. E, estimate when the rocket started to fall. So when the rocket started to fall is right here, where instead of above, it's below. So I need 2 points, 2 and 200. And the other one, I need a point down here, which is at like 10 and -50. That made a line. Next, I'm going to find the slope between these points. So the change in y over the change in x. So -50, subtract 200. 10 take away 2. I'm going to simplify it. So it's -250 divided by 8. So what is that? -125 divided by 4. I don't think anything goes into it like that. But anyway, there's the slope. Take a point that you think is easier. So I'm just going to take 2 and 200. And then you make it equal to 0 and solve for x to get the approximate answer. So I got -125 over 4, x minus 2, subtract 200. To get x minus 2 by itself, you multiply times the reciprocal. So if I simplified this, definitely 5 goes into both evenly. That's -50, 5. That's -40 times 4, 5. That is 25. 5 goes in again. That's -8. So I get -32 over 5 as an approximation. That's like 6 point something, right? Did I get that right? I made some mistake down here somewhere. If I look at it, I can see it's between 8 and 9, and you can approximate it. It did say estimate? Estimate when the rocket started to fall. So I don't need to find the exact answer. So what am I doing to myself here? Just causing myself a headache. So if I'm going to estimate, it's like 8 and a little bit. So like 8.3 seconds. A little bit past 8 if you can estimate when it started to fall. F, estimate again. So I'm going to estimate. When is the acceleration was the greatest? So when is the slope the most pointed up? So acceleration, if it's negative, it's negative. So a negative number doesn't help. So I'm looking at the slopes here. And right at the very beginning is when the acceleration is the greatest. So when I look here, so approximately acceleration is greatest just before 2 seconds. So here, here. And then just before 2 seconds, where is this the steepest? So right before 2 seconds. Last question. G. When was the acceleration constant? This one's an easy one. So, when did the slope stay the same? So the acceleration was constant from 2 all the way to 10. That line is a constant slope. That means the slope stayed the same between 2 and 10. That is the acceleration. Right? Real world situation, knowing how to interpret a graph, even listening to me as I'm working through the graph, thinking through it to try to get the best answer I can through it. That is awesome practice. Real world situation. All right, Mr. G Math, over and out. I'm proud of you that you did your work, and until next time.